Today we're going to talk about alkenes and alkynes. So this is an extension for our lesson, or from our lesson on naming alkanes and even naming branched alkanes. Once again, an alkane is a hydrocarbon where the carbons are all connected with single bonds. An alkene is a hydrocarbon where I may have some double bonds in there. And an alkyne is a hydrocarbon where I may have some triple bonds in there. So we're going to talk about both of these things. And although you're like, oh gosh, she's giving me two topics to do here in one lesson, I feel like a lot of the organization kind of makes a lot of sense because we've already had our lesson in naming alkanes. So hopefully the translation, just to take it a step further and now throw in some double bonds or some triple bonds, might not be that much of an extra stressor of an extension. So I'm excited. We're totally going to be using a highlighter today so we can highlight our parent chains because we love how to do that. And then obviously a pencil. So let's get started on learning about our alkenes. So alkenes are hydrocarbons containing double bonds. So here I've got an ENE ending. So that alkene, and when I see an ENE ending, that is a red flag to let me know that I will have a double bond in this hydrocarbon molecule. Okay, so they are unsaturated, which just means the double bond itself will prevent carbon from being able to connect to four other things. Okay, we know that carbon can only have a total of 8 valence electrons when it makes bonds. So if I make a double bond itself has 2 shared pair of electrons. A double bond itself is containing 4 of those 8 valence electrons. So carbon will only have the possibility of making 2 other bonds in addition to that double bond. This is hopefully a review from what we've learned about with drawing Lewis dot structures in our covalent bonding unit, but now we're going to see how it affects these hydrocarbons. So we call that unsaturated. When you can't pack all the hydrogens you would want to pack around every single carbons like we did in the alkanes, that's an unsaturated situation. The molecule is not completely saturated with hydrogens because I'm having situations where electrons are not available for hydrogens, but they're being trapped in multiple bonds. Okay. I feel like I talk a lot sometimes, you guys, but I just get excited. Okay, the ending, as I mentioned, is going to be the ENE ending. That lets me know I have a double bond. Now, my molecular formula, meaning if I wanted to figure out how many hydrogens my molecule has, depending on the carbons in an alkene, I'm looking at this right here, and I can zoom in. Okay, this right here, it tells me that the number of hydrogens are just going to be 2 times whatever the number of carbons are. Okay, now this is specific for an alkene that only has 1 double bond in it. There are possibilities for alkenes that have 2 or 3 double bonds even in it, but if I'm looking at 1 double bond in the hydrocarbon, that the number of hydrogens will be exactly twice the number of carbons. Okay, now I can totally throw a prefix, and I totally will throw a prefix in front of this "ene" ending to let me know, well, how many carbons are in that parent chain of the molecule. The prefixes are exactly the same. We know me eat peanut butter, so here's an eth for 2 carbon atoms. Here's a prop for 3. I could continue on with 4, 5, 6, etc., right? One thing every year kids are like, well, where is the meth? Why can we not have methene? Well, you guys, in order for you to have a double bond between carbon atoms, you must have more than 1 carbon atom, so you will not see a methene. That would just not be possible for us. So kind of standard. I'm just looking at changing the ending to "ene," which we like that. Okay, so now let's do steps for naming alkenes. It says the parent chain must contain the double bond, even if it is not the longest chain in that hydrocarbon. Okay, so let's look at what we got going on here. Let's see. So I got this guy right here, and we know we like to find that parent chain, right? Oh, I also see that we're going to maybe have some branches to tackle too, which yes, we will. But I'm looking, and I notice that if I go this way, 1, 2, 3, 4, 5, 6, versus this way, 1, 2, 3, 4, 5 over to the double bond, 6 is a longer chain than the 5 that has the double bond. But here's the sneaky thing. You have got to make that double bond be in the parent chain. So that means my parent chain that I'm committed to is going to be this guy over here. Okay. All right, so we love this. Okay, so the longest continuous chain of carbon atoms, including that double bond, is 1, 2, 3, 4, 5 carbons. So this gets me started. I'm getting excited. Okay, so we know we have 5 carbons in our parent chain, right? And we know that that parent chain has a double bond. So 5 carbons, we know the prefix is pent, right? And a double bond means we got to end with a "ene" ending. Putting those things together, you guys, we would name this parent chain a pentene. Okay, so that's amazing. Okay, I'm also going to now number the carbons in the parent chain by starting at the end that is closest to the double bond. Well, obviously, the end that is closest to the double bond is this end right here. I will give you a heads up. The double bond is more important than any branching alkyl groups. Meaning, if my double bond looks like it's further into the molecule, than a branched group is, I'm still going to start my numbering system according to the double bond and not my branches. Branches are a secondary thing. If I do not have double bonds, if I have an alkane, then yes, my branches will determine who carbon number 1 is. Okay, so here we go. It was a tangent. You know I like to do my tangents. So that's going to be your carbon number 1. This is going to be your carbon number 2. This is going to be your carbon 3, 4, 5. Awesome. So our parent chain is called pentene, and we see that double bond following carbon number 1. All right, let's zip on down to the next little guided section on naming this guy. So I'm going to repeat my highlighting for this new picture so I can remember what information I've collected from the very first step on naming. So we figured out the parent chain. We know how many carbons are in that parent chain, so we use it pentene. So it says the position of the double bond is indicated in the name by stating the number of carbon atoms in the parent chain stating the number of the carbon atom that the double bond in the parent chain follows. Okay, so what this means is that I cannot just say pentene, woo, see you later. How would I know if I did not see this structure where in those 5 carbons the double bond is? Because it could potentially be anywhere. So I've got to tell you what carbon the double bond is following. So it looks like my double bond is following carbon number 1. So I would call this a 1-pentene. That lets me know that I've got 5 carbons in my parent chain, and that double bond is coming right after the first guy, right? And as I mentioned, there could be potentials for us having 2 double bonds or 3 double bonds in there, which if that's the case, you're just going to write all of the numbers of all the different carbons that those different double bonds follow, okay? So if there's more than 1 double bond, you're going to indicate all of the carbons with a double bond by a number. And if there are 2 double bonds, you actually call it not just ene, a diene. And if there are 3 double bonds, you're not just going to call it ene, you're going to call it a triene. We do not have that in this specific situation, but we will get to some example problems down here in a little bit to where we can kind of practice doing the dienes and trienes. It's kind of fun. Okay, so yes, we're looking good here. We're looking good here. Step number 3, it says, now we can focus on my branches. I was ignoring my branches, but I do have them, right? So I'm going to locate and name the branched alkyl groups, and then I will have the name for my alkene. So I'm going to re-highlight my parent chain. I'm going to renumber my carbon atoms. Cool. And now I'm looking at that branch group. I'm like, oh my goodness, you guys. That branch group is a 2-carbon branch group. So that is an ethyl group, right? So I'm going to identify that there's an ethyl branch group on this hydrocarbon. And I'm also going to tell you where that ethyl group is coming off. It looks like it's coming off of the 2nd carbon, right? So I'm just going to write that this is a 2-ethyl. And then since I am a double bond situation, that is where I will then put the dash indicating the location of the double bond on this pentene molecule. So we have a 2-ethyl, 1-pentene. Very cool. Okay, let's do some more practice because this is super fun. All right, some practice. We have here for this first example, it does not look like I have any branches, so I basically only have one option for a parent chain. So I'm still going to highlight it anyway because this is my emotional support highlighter, I feel like, when it comes to organic chemistry. So now I see, oh, I've got a double bond there, right? Okay, well, I've got to start my carbon number 1 at the end that's closest to the double bond, which it's going to be this carbon. So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, 5, 6. It is a 6 carbon parent chain, so this is a hex. Double bond means a hexene. Okay, I also have to tell you what carbon the double bond is coming off of, and it is coming off of carbon 2. So this is 2 hexene. Yes, pretty simple one, but I think that does a great job of reinforcing, like making sure that we're numbering our parent chain according to where the double bond is and what side that's closest to. All right, next one down. No branches on this one. Y'all are like, great, this practice is so easy. I'm gonna give you some branches on the back, so do not worry. So we got one branch system, so one possible parent chain. It looks like there are 5 carbons in this parent chain, so this is a pentene, right? But oh my goodness, for the first time, you guys, I got some double bonds. Yeah, I've got 2 double bonds. So not only is this a pentene, this is a pentadiene. Okay, so let's see. I got to number my guy based on which end of the molecule is closest to the first double bond, now that I have 2 options here. So it looks like if I start numbering here, I hit a double bond immediately, versus if I'm over here, I do not run into my first double bond until the second carbon. So we're going to start our carbon number 1 right here. So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5. Okay. So since there are 2 double bonds, I've got to represent what number of the carbon both of those double bonds are coming off of. So I've got a 1 is where my first double bond is coming off of, and a 3. The second double bond is coming off of the third carbon. And so then I'm going to say, and it is a 5 carbon long hydrocarbon, so it is a pent. Because there are 2, I say pentadiene. So pentadiene. Pretty cool. I love when you're naming these organic structures. It just feels like you're just bubbling out just letters of the alphabet to where you create these crazy, almost made up words. But there is some logic behind constructing these words, even though you may get some wild looking names. Okay, so now let's flip to the back. We got some more practice on the back, which we love. Okay, so I've got now a branched alkene for us to name here. So I've got to include my double bond in the parent chain, even if it is not the longest. It looks like my double bond will be a potential longest parent chain. There is another one that is equally as long, but it does not contain the double bond. So we are going to choose this guy right there, right, as our parent chain. Okay, so now we are ready to establish our numbering system to figure out who carbon number 1 is going to be. Well, carbon number 1 has to be the one closest to the double bond. It's got to be this guy, right? So this is my first carbon. That's my second carbon. That's my third. And that's my fourth, okay? So I can... And, you know, sometimes when you got a lot of stuff happening here, I kind of like to write the root or what the actual parent chain is without all of the special alkyl groups that I know I'm going to have to blast in the front. So we know that this is a 1-butene because 4 carbons, bute, me eat peanut butter is 4. So bute. So this is a 1-butene. Sometimes I kind of like to write that down first, and then I can zone in and tackle whatever alkyl groups I have to name. So that's a 1-carbon alkyl group. 1 carbon means a methyl group, and it is coming off of the second carbon. So I would write 2-methyl And then to continue on, that's where I would get the 1-butene. So 2-methyl-1-butene. Awesome. Okay, next one. I think my highlighter, here we go. I got my highlighter. So this next one we have, okay, I need to pick the longest continuous chain of carbons, but y'all, I have 2 double bonds. That parent chain better grab both of them or else I am in big trouble, right? I cannot go up here. I know it is more carbons to go up there because I'd be missing out on my double bond here. So I'm going to grab the parent chain, which has the double bonds, and I feel real good about that. Yes? Okay, this looks like it's another butene, but it's got 2 double bonds, so it's a butadiene situation here. Now this one is fun. To figure out which carbon is carbon number 1, we know that we want to start at the end of the closest, in this case, first double bond that I would hit. I hit a double bond immediately, no matter which way I start here. Then that means I have to look at the next indicator on which would help me name carbon number 1. And I notice I have a branch here. So since my double bonds are not helping me decide who carbon number 1 is, they would both be the same. My branch group is going to be the determining factor here. And this branch is closest to the first carbon. So we're going to write branch closest to first carbon. So the order of operations here is you first look at your double bonds to help you with carbon numbering. And then if they are not helpful, you will look at your branch groups as a secondary aid there. Okay, so that means we're going to start here with carbon number 1. And in fact, oh my gosh, you guys, you can barely see. Wow, okay, this is a great picture that I stole from the internet. They already have the carbons numbered, but I'm glad we had this conversation. So that's carbon 1, that's carbon 2, that's carbon 3, and that's carbon 4. Okay, amazing, 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 amazing. Okay, I want to write down this whatever diene structure that we have here. It is a 4-carbon double bonded structure, and it's got 2 double bonds, so it is going to be a butadiene. And the double bonds are coming off of carbon 1 and carbon 3. So the ending part of this name is for sure going to be 1,3 butadiene, right? Now I'm going to tackle that alkyl group. It is a 2-carbon ethyl group coming off of the second carbon. So in front I will write 2-ethyl, and then that dash, I smeared my pencil to indicate the 1,3-butadiene. Cool. Okay, now I'm going to give you a name, and I want for you to write the structural formula where y'all start with the CH3 dash, CH2 dash, and all the stuff, and then you accommodate the branches and things, right? And filling in the hydrogens where they're needed in order to make sure that carbon's always got 4 bonds in some way. And then we're going to condense it down to where we're going to make it one line of the hydrocarbon with the information indicated in there without like branching up and down. Okay, y'all are like, we know, move on. I'm like, well, maybe you've forgotten, so let's remind ourselves. Okay, the interesting thing here is because of that double bond, it's maybe going to affect how many hydrogens we have to end up filling in on these, and we'll get there when we get there. So I got a 3,4-dimethyl 2. Wow, whoa, oh my goodness, y'all always start at the end. What do we got going on here? I see pent. That means 5. I also see an ene. So my head is up. My head's up. I'm ready for it to have a double bond somewhere in there. So I can go ahead and knock out 5 carbons in a row. Once again, we like to give ourselves a little bit of space around the letter C, because if we need to do some hydrogen adding in, then we can have some space to put it in there. Okay, so I also see a number that tells me where that double bond is coming off of. The double bond is coming off of the second carbon. This is super important because that means I'm going to change that to a double bond line. Yes? Okay. So we've tackled the 2-pentene part. Now we're ready for the alkyl groups, the branch groups coming off of it. I have a dimethyl. Dimethyl situations means I will have 2 separate CH3 groups, right? In those CH3 groups, one of them will be coming off of the 3rd carbon. So here is my 3rd carbon, so I will give him a CH3. And then I have my 2nd methyl group coming off of the 4th carbon. So here's my 4th carbon. I'm just going to make him go down. That sounds good to me. Okay, that is all the information from the name. Now I got to fill in my hydrogens. Okay, We got over here my little carbon on the end. He's only got one bond right here, so he has a potential to make 3 more with 3 hydrogens. So this is a CH3. We're starting to get used to my ending guy at the end of a branch being CH3, CH3. But now I'm going to come here. And y'all are like, we are used to those carbons in the middle, CH2. Whoa, he's attached to a double bond. Remember, every time you see a line, it represents 2 electrons. That double bond already got 4 electrons in there. And then he's got now 6 from that bond. He can only bond to 1 more hydrogen. So if I were to visualize this, I'd be drawing a line up and then a hydrogen, and that would give you 1, 2, 3, 4 lines, the 4 bonds that carbon is only allowed to make. So to tell you that he's only bonded to 1 hydrogen, I'm going to just put 1 letter H. Cool. All right, moving on down. Let's check out this carbon. Okay, yeah, he's already got 4 bonds. 1, 2, 3, 4 bonds. So that's 8 total valence electrons. He does not have any additional hydrogens, okay? So he's just a C. That is super fun for me. I rhymed. Oh my gosh, I'm losing it today. Okay, now the next carbon over, he's got 1, 2, 3 bonds. He needs a 4th bonding partner, so we will give him a hydrogen, right? And then finally, my guy at the end, he is only got a single bond connected to him, so he will be bonding to 3 hydrogens, right? That looks good to me. Well, I mean, it does not look very pretty. It's a little bit wonky and shaky, but that's okay. It is a correct structure, and that is all that I'm looking for. So now my condensed formula is where I just focus on each carbon in the chain and give you in parentheses if there's anything important coming off of him, what that important branch group is. I'm going to show how it looks a little bit different now that I've got that double bond to show you here. So I'm going to start off like normal. I got CH3 over here, this guy, right? And then the next guy, he's a CH. Where you have a double bond, you actually must draw that in this condensed formula. So I'm just going to show you, hey, that's the double bond right there. Then my next guy is just a C, and he's bonded, or he is attached to, or he has got a branch group attached to him. So to show that attachment, I will put that methyl group in a parentheses. Then my next carbon is a CH carbon. He also has a branch group. He's got a methyl group. So I put that methyl group in parentheses. And finally, the very last parent chain is our very last carbon on the parent chain is a CH3. Okay, yeah? So double bonds, it's a little bit fun, not too challenging. The main thing is the ending is -ene, and that double bond is the main establisher of finding who carbon number 1 is. Okay, and it has to be in the parent chain. Double bond needs to be in the parent chain or else you cannot do. Okay, next one, alkynes. I got my alkynes, you guys. How fun is this for us? Alkynes. Okay, alkynes are hydrocarbons that contain triple bonds between carbon atoms. And they are unsaturated also, because remember, every time I take multiple bonds, I'm removing an opportunity for carbon to be saturated with hydrogens, right? And in fact, a triple bond is going to really limit some of my carbons here in the structure. The ending of an alkyne is -ine. My molecular formula, meaning if I want to know how many hydrogens I have in a alkyne with a certain number of carbons, it's going to be double the amount of carbons and then subtract 2 from it. Okay, now this is only the formula for if I have a hydrocarbon with only 1 triple bond. If I have multiple triple bonds in there, you do not get to use this thing, which I will not be mean and make y'all, whatever. Okay. Prefixes, totally the same, you guys. I'm not going to have a methane because in order to have a triple bond situation, you need more than 1 carbon atom. So we start at 2. I can have an ethine. I can have a propyne, right? I can have a butine, pentyne, all that fun stuff. Okay. It says the same rules for naming an alkene apply here. However, the ending is -ine instead of -ene. So that was some simple directions, okay? That's it. I got to start my carbon number 1 at the end closest to that triple bond. Make sure that parent chain contains the triple bond. If there's more than 1 triple bond in there, I would say a diene and tell you which carbons those things are coming off of. Let's do our first practice. I've got my highlighter ready to highlight my parent chain. I do have a branch to consider, but it does not look like that branch is making me want to go down there for the longest continuous carbon chain. Also need to make sure my parent chain contains that triple bond, right? Starting my numbering system on the triple bond is the most important thing. In other words, I would not care if this methyl group was like way over here, okay? I'm really going to be focusing on where that carbon is, okay? So, or that triple bond is. So I've got carbon number 1 here. This is carbon 2. That's my carbon 3, carbon 4, and carbon 5. So this is a 5-chain triple bonded hydrocarbon. So it is a pentyne. And that pentyne or that triple bond is coming off of the first carbon. So as I like to do, let's just go ahead and call it, this is a 1-pentyne. I know, it's so weird, pentyne. Okay, but we do have a branch group to take care of here. We have got a methyl group coming off of the third carbon. So we have a 3-methyl. I did not give myself enough space. 1-pentyne. I'm not happy with that. I will erase that because I do not want y'all to be confused. Let's see. I feel like my 1 is a little bit shaky here. Let's see. So 3-methyl 1-pentyne. Yes. Amazing. Okay, next one, maybe some more confusing branch structures to accommodate for. I've got to get this arm right here because it contains my triple bond. So I'm either going down here, that looks like that's only 5. I'm either going here, that is also 5. Let's check out going down here. 1, 2, 3, 4, 5, 6, 6. Yes, so that will be my parent chain. Okay. I also know that I need to start carbon number 1 at the end closest to my triple bond. So that's carbon 1, 2, 3, 4, 5, 6. So 6 is hex. This is a hexyne molecule. So, and then it is specifically a 1-hexyne. So 1-hex. Looks so weird, yne. Okay, I do have some branch groups to take care of here. I have got a methyl group there coming off of carbon 4. I got an ethyl group here coming off of carbon 3. So as a review from last lesson, if we have different types of alkyl groups, I've got to do my naming system alphabetically. An ethyl group, E comes before methyl M in the alphabet. So I need to name my ethyl group first, okay? So my ethyl group is on carbon 3. So I may have to write some of my name up really far above here. So I got a 3-ethyl dash. The next branch group I'm going to name is my methyl group coming off of the 4th carbon. So I would say 4-methyl. And then 1-hexyne. 3-ethyl, 4-methyl, 1-hexyne. All right. Okay, so moving on. So what I have here on this next problem is I'm going to need this section of my molecule because it's got the triple bond. And so I've got some options of pathways I can take. If I went straight across, 1, 2, 3, 4, 5, 6. If I went up, 1, 2, 3, 4, 5, also 6. If I went down, 1, 2, 3, 4, 5, also 6. It does not matter. Choose your own adventure. For just the look of simplicity, I'm going to go straight across. Okay, so we're just looking at the carbons. This is super fun. Where I start carbon number 1, I'm hoping that my triple bond tells me some information, and my triple bond I think is directly in the middle, meaning if I started carbon 1 here, it would be 1, 2, it would happen on 3, or if I started carbon 1 here, it'd be 1, 2, also on 3. Okay, so I have used up all of the availability of my triple bond helping me. Now I need to look at those branch groups. And I do have 2 branch groups. And the end of the molecule that they are closest to is this end. So this is going to be my carbon number 1. 1, 2, 3, 4, 5, 6. So it is a 6-carbon triple bond hydrocarbon. It is another hexyne. Okay, and the triple bond is coming off of the 3rd carbon. So I'm going to call this, I'm going to give myself a little bit more space for me to write my branch groups because I think I'm going to learn my lesson from last time. So this is a 3-hexyne. 3-hexyne. All right, my alkyl groups, they are both the same. They are methyl groups. And if I have more than one of the same type of alkyl group, I would say a di. So a di, or a tri if you have 3. So this is diethyl, or dimethyl group. Sorry, you guys, methyl. And then I would indicate which carbons the 2 methyl groups are coming off of. They are both coming off of carbon number 2. So I'm going to call this 2, 2 dash diethyl. and then dash 3-hexyne. 2,2-diethyl-3-hexyne. Amazing. Okay, now let's practice drawing some of these structures. Okay. Oh my gosh, so many numbers and things. Let's zone in on the ending. What do I have going on here? A pentyne. Oh, I know that pent means 5 carbons, and I see the I or YNE. I know I'm going to have a triple bond in there. Where the triple bond is right there on the second carbon. So I'm going to go my first carbon out of the 5. Here he is. And then I have a single bond. And then my next carbon, this is the one that I told you it has a triple bond on. So I can go ahead and write in that triple bond right here. And then I've got another carbon. And then I've got another carbon. And then I've got my last carbon. Hopefully I left enough space over here on this side. I was kind of getting it close together. That is okay. All right. So now I've got to look at my branch groups that they're telling me so I know where to put them. I have dimethyl, 2 methyl groups coming in here, both on the 4th carbon. So 1, 2, 3, 4. That's my 4th carbon right here. So he gets 2 methyl groups, one above and one below. Yep. And that is all the branching and things that I need to take care of. Now I just got to saturate the rest of the molecule with as many hydrogens as I can fit, keeping in mind that carbon can only make 4 bonds. So I got the first guy. Hello, CH3. We know that you can have 3 hydrogens. Now here's where triple bonds get fun. This next carbon, he already has 4 lines coming off of him. He's got 8 valence electrons. He does not have any more availability to bond to any hydrogen. So that's just C. And then over here, same thing, you guys. He got 4 bonds already. He does not have any ability to bond to hydrogens, just C. Same thing over here, you guys, but for different reasons, not because of a multiple bond, just because he's already bonded to 4 things with 4 single bonds. He's satisfied, but then I got to tackle my guy here at the end and give him 3 more hydrogens to bond to complete his octet. Amazing. So that is the structural formula of 4,4-dimethyl-2-pentyne. And now I'm going to condense it down and write it. Okay. So I have got, can we still see? Amazing. Okay. So I've got CH3 as my first guy. And then my next carbon is a C. And just like in our double bond example that we did up here where I had to actually show the double bond inside of my condensed formula, I'm going to show the triple bond also. So I'm going to put in that triple bond, and there he is right there. Then I'm going to hit my next carbon on my parent chain. And that's all he's got going on there. And then I hit my next carbon in my parent chain. Yep. And on that carbon, he's got 2 of the exact same branch groups. So I can do that fun thing where I can go CH3 and then to tell you I got 2 of them on that carbon right here. He's like, hey, there's 2 of those entire guys. And then finally, my last guy, my last carbon in that parent chain is a CH3. All right. So that was our hopefully not too challenging of an extension lesson tackling these double chain or double bond alkene groups, our double bond alkene structures and a triple bond alkyne structures. They are more important in our numbering system on that parent chain than my branch groups, keeping that in mind. And no, for this first introduction to naming these organic structures, I will not give you molecules where you will have both a double bond and a triple bond in there. That is just cruel for me. That is something for you to look forward to later when you get to college. But this is our fun lesson today.